Okay, so this video is about lesson 5.2, and we're going to talk about some properties of parabolas and specifically how to graph them. So we're going to start with graphing a parabola that looks like this. It has that x squared term and then it has some constant added to it afterwards. We call this a parabola that's in the form ax squared plus c. There's no middle term, so sometimes you'll see parabolas written like this, where you have this x value, this linear term. If that's not there, then graphing a parabola is a little bit easier. So we're going to talk about this. When you graph a parabola that's in this form, y equals ax squared plus c, the vertex is really easy to find. The vertex is the y-intercept, and the y-intercept of any parabola, not just one in this form, any parabola in standard form, is 0, c. Okay, so when x is 0, then this constant term out here is where it's going to cross the y-axis. Because if you plug a 0 in here for x, then this term goes away and you're just left with 4. So 0, c is going to be your vertex. In this case, it's always your y-intercept, but in this case it's your vertex also. So let's find that point. When x is 0, y is 4. So 0, 1, 2, 3, 4. In this case, that's your vertex. And what that means, what we learned in the last lesson, is there's an axis of symmetry that goes through that vertex, and the graph looks the exact same on both sides of that axis of symmetry. So the strategy for graphing this is pick some points x over here and figure out what y would be, and then graph them on this side, and then find their reflection over here, since it looks the exact same on both sides. So let's plug in 1 for x and see what we get for y. Y equals 2 times 1 squared plus 4, which is equal to 2 plus 4, which is equal to 6. So when x is 1, y is 6. 1, 2, 3, 4, 5, 6. When x is 2, what is y? Y is equal to 2 times 2 squared plus 4. 2 squared is 4, so 2 times 4 plus 4 is equal to 8 plus 4, which is 12. So when x is 2, y is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're way up here. Alright, so this is what one side of our parabola looks like. I'm going to go ahead and draw it in blue so that it's easy to see. Wow, I'm terrible at graphing with this tablet pen. Okay, so that's one side. Well, what we know is if this point right here is 1 away from the axis of symmetry, then if we go 1 more on the other side, we have a point over here. So this is one of the points on the other side. And then if we went up here to this point is 1, 2 away from the axis of symmetry. So if we go 1, 2 more, there's another point. So we had the point 2, 12. That means we have the point negative 1, 6, and negative 2, 12 as points also. So that's how you graph it. You find the vertex, which if it's in this form, it's 0, c, and then you plot points on one side of the axis of symmetry and find their reflection. Okay, when it's not in the form y equals ax squared plus c, it has this middle term right here, and so it's in this form, y equals ax squared plus bx plus c. So we're going to talk about, this is standard form for a parabola, and we're going to talk about what these constants do. So we've already said in the last problem, the y-intercept, I think I was like, I'm missing something. Intercept is 0, c. And that's going to be true in standard form also. If you plug in 0 for x, this term and this term both go away, and you're just left with c. So the y-intercept is here at 0, c. Also, if a is a value that's bigger than 0, if it's a positive number, then the parabola is going to look like this. It's going to go up. But if a is less than 0, then it's going to look like this. It's going to be a parabola that goes down. Now the most important thing that we're going to talk about in this form is that when you have something written in standard form, the axis of symmetry is at this value, negative b over 2a. That's something you'll want to memorize for when you're working with quadratic formulas, because negative b over 2a, this is the b and the a value that I'm referring to, is always your axis of symmetry. And that's really important because the axis of symmetry of a parabola always hits the vertex. The vertex of the parabola is the point on the axis of symmetry. So if it looks like this axis of symmetry, this point is going to be negative b over 2a. That's going to be the x value of this point, and the y value of this point is whatever you get for negative b over 2a, and then you plug it back in for x, you'll get some y value. So I could write it like this: f of negative b over 2a, if the function was written like this. F of x is ax squared plus bx plus c. The vertex is always going to be this point. Negative b over 2a is the x value, and then when you plug that x value back in and evaluate it, so when I plug that x value back in and evaluate it, I'll get a y value, or a value for my function, and that is the y value of my vertex. If I go back to this problem, I said my vertex is at 0, c, which is the y-intercept. Well, the vertex is always at negative b over 2a. In this case, there's no b value, so b is 0 and a is 2. So that would be 0 over 2 times 2, which is 0 over 4, which is 0. So x is 0. We already saw that. And then if you plug 0 back in, you get the c value of 4. And so you can find that even if it's in this form, but you don't really have to do that. If there's no b, the vertex is going to be at 0. Okay, so let's use that to graph this equation. We're going to graph the function, label the vertex and the axis of symmetry. The first step is to find the vertex, and the way you find the vertex is by finding the axis of symmetry. So I guess the real first step is find the axis of symmetry. X equals negative b over 2a. So in this case, b is 4, so negative 4 over 2 times a, which a is what goes right here. It's nothing written, so that means it's 1 times x squared. So negative b, 4 over 2 times a, is equal to negative 4 over 2, which is negative 2. So the vertex is at negative 2 comma something. To figure out the y value, I got to plug this back in. So y is equal to x squared. In this case, x is 2, because we're plugging this back in, plus 4 times x plus 1. That's equal to 4 plus negative 8 plus 1, which is equal to 4 plus negative 8 is negative 4 plus 1, which is equal to negative 3. So the vertex is at the point negative 2, negative 3. Let's make some space to actually draw the graph. And remember, my axis of symmetry is the x value of this vertex. So at x equals negative 2, I have a vertical line. Let me go ahead and draw that on here. I'll do it in red. There is my beautiful axis of symmetry. And it is the line x equals negative 2. My vertex is at negative 2, negative 3. So this is the point, the first point of the graph. And then the rest of this you do the same way that we did the first problem. You find a few points on this side of the graph, and you also graph their reflection. So let me find a few x and y values. I'm going to pick the y-intercept because it's easy. I know it's always going to be at 0, c. So when x is 0, y is this c value over here. If I plug in 0, this term and this term both cancel out, and I'm left with 1. So that's 1 point, 0, c. Oh, that's not the right spot. 0, 1. At this point, it's 1, 2 away from the axis of symmetry. So if I go 2 on the other side, I have this point, which is 1, 2, 3, 4. Negative 4 for x, 1 for y. So there's 2 points. Let me find another point. I'm going to plug in 1 for x. When x is 1, what is y? So y equals x squared plus 4 times x plus 1. So that's 1 plus 4 plus 1, which is 6. So when x is 1, y is 6. 1, 2, 3, 4, 5, 6. And that is 1, 2, 3 away from the axis of symmetry. So if I go 1, 2, 3 on the other side, here's my other point, and that's at 1, 2, 3, 4, 5, negative 5, 6. So now I've got a couple points, and I can graph my parabola. Your parabola is not supposed to be a squiggly line. It's because I can't control my hand. That's better, sort of. Anyway, so that's how you graph a parabola. I knew that this was going to go up beforehand because my a value was greater than 0. A equals 1, and so that means it goes up. If it was a negative number, then this would be facing down. Okay, graph the function, find the minimum and maximum value. So this, find the minimum or maximum value, is the type of question that you'll see often with parabolas, especially in a real-world context, because it's one of the most valuable things that you can get from this. So how do you find the minimum or maximum value? Well, if you look at the shape of a parabola, if this was our parabola and I said, what is the smallest value on here? Okay, the smallest value is going to be down here. That point, our vertex, is going to be the smallest point. The maximum of this, there is no maximum. It just keeps going up forever and ever and ever and ever. So there's no maximum, but there is a minimum. If I had a parabola that was shaped like this, and I said find the maximum would be here, my vertex again. And the minimum, there is no minimum. So with a parabola, there's either a maximum value, max, or a minimum value. And that point is always the vertex. So when they ask you find the maximum or minimum value, they're saying find the y value of the vertex. So that's what we're going to do. So if we're going to find the vertex, we first have to find the axis of symmetry. Let's go ahead and write standard form again. Ax squared plus bx plus c. So a is negative 2, b is negative 3, and c is 4. If you often get this mixed up or you have sign problems, it might be a good idea to actually write this down every time. So we're going to graph the function, then find the maximum and minimum value. So x is equal to negative b over 2a. That's the axis of symmetry. So in this case, that's negative 3 over 2 times negative 2. So x is equal to 3 over negative 4, or negative 3/4. So our axis of symmetry is at x equals negative 3/4. So that's about there, something like that. Sort of how my graph looks. Okay, and then we got to find the y value. So this is the x value of the vertex. The vertex is negative 3/4, comma, something. And we got to plug it back into this equation to find out what that is. So let me make some more space. Y is equal to negative 2 times x. In this case, we're interested in negative 3/4. X squared minus 3 times x plus 4. So y is equal to negative 2. Negative 3/4 squared is the same thing as saying negative 3/4 times negative 3/4. Negative 3 times negative 3 is a positive 9. 4 times 4 is 16. So this is 9 over 16. Negative 3 times negative 3 is a positive 9 over 4. You could think about this as 3 over 1 if you're having trouble with fractions. And then plus 4. Doesn't change. I'm going to erase that for now. Okay, so y is equal to negative 2 over 1 times 16. The negative 2 and the 16 are going to cancel out, or the 2 and the 16, and we'll be left with negative 9 over 8 plus 9 over 4 plus 4. I'm going to write this with the 8 on the denominator so I have a common denominator. So that's going to be 18 over 8 if I multiply them both by 2. And this with an 8 on the denominator is going to be 32 over 8. So if negative 9 plus 18, so this is what we have now. Negative 9 plus 18 plus 32, which is equal to 9 plus 32, which is 41 over 8. So this is our y value of our vertex. So we got fractions for our x and y value of the vertex, and that's perfectly fine. A parabola can start anywhere. All right, so here we go. The vertex is at negative 3 over 4, comma 41 over 8. If you like decimals better, that's negative 0.75, comma 8 goes into 45 times, and then there's 1 over 8, so that's 0.125, I think. I hope. Anyway, it's close to that. Yeah, that's right. I don't know why I was having a hard time thinking about that. 1 over 8 is half of 2 over 8. It's half of that, right? And 2 over 8 is the same thing as 1/4, so it's 0.25. If I did 0.25 divided by 2, I'd have 0.125. So I should have had that memorized, but for some reason I couldn't remember it. So I had to think through this in my head. That was an aside. So let's graph our vertex. Negative 0.75, comma 5, 1, 2, 3, 4, 5, 0.125. That's about here. I'll just draw a big dot and make sure I get it. Okay, so now that we have our vertex graphed, we need to pick a few x values and find their y values. So I'm gonna do the y-intercept, because I always like doing the y-intercept. When x is 0, these two terms get canceled out, and y is 4. So 0, 1, 2, 3, 4. If I go 0.75 over to this line, I need to go 0.75 more, and I'll be here. So that's at 0.75, and 0.75 is 1.5, comma 4. Okay, now I need to find one more point, so I'll just plug in 1 for x. Y is equal to negative 2 times 1 squared minus 3 times 1 plus 4 is equal to negative 2 minus 3 plus 4, negative 5 plus 4, which is negative 1. So when x is 1, y is negative 1. So 1, negative 1 is here. I go 1.75 over to my line, so I need to go 1.75 more, and I would be here. And that is the point 1, 2.5, so negative 2.5, comma, negative 1. So now I can graph my parabola. So there's the graph, and it said find the maximum or minimum value. In this case, we have a max, and our maximum is our vertex, which was negative 3/4, comma 41 over 8. That is the maximum value of this function. Okay, so now let's use that in a real-world type example. Okay, you have some company has decided that producing tires costs them this much. Okay, this function models how much it costs them to make tires. X is the number of tires produced, and C, or what would normally be called Y, is the cost of making those tires. So very, very important question would be, how do we minimize the cost of making our tires so that we can make the most? How many tires should we make to minimize that cost? So what we want to know is, what does this function look like, first of all? This little bitty number is a positive number. There's not a negative sign there. And so that means this parabola is going to look like this. That's going to be the basic shape. It's going to be opening up. So we're looking for a minimum value, and that's our vertex. We want to know how many tires. So in this case, we've got X, which stands for how many tires, and C for the cost of those tires. We want to know how many tires will minimize the cost. So let's find the x value of our vertex, which is at negative b over 2a. In this case, A is equal to 0.12345. 4 zeros, 1 5. B is equal to negative 0.03. So negative B over 2A is equal to 0.03 over 0.12343, because it's 0.03 over 30 now. I'll go ahead and write that because 2 times 15 is 30. So now this is the same thing as if I have two decimal places here, that's the same thing as 3 times 10 to the negative 2. And this is the same thing as 3 times 10 to the negative 1, 2, 3, 4, 5, negative 5. So I'm going to have 1. The 3's are going to cancel out. And then there's more negative numbers here. So if I was to move this to the top, it would be 3 times 10 to the negative 2, 3 times 10 to the 5, 10 and 10, 10 to the 5th, that's going to cancel out and give me 10 cubed. So I should have 1,000. 1,000 tires would be the cost. You can also say 0.03 divided by 0.12343, and you'll get 1,000. Okay, so the x value of our vertex is 1,000. So if you produce 1,000 tires, then that will minimize your cost. And what is the cost for that number of tires? So you got to plug that back in. 1,000 squared minus 0.03 times 1,000 plus 35. That's equal to 0.1234415. 1,000 squared is 1,000,000. We have 3 zeros and then 3 more zeros. Negative 0.03 times 1,000 is the same thing as negative 30, because you move this decimal place 1, 2, 3 times and you get 30. This is 35. If I was to move this, I got to move it 6 times. 1,000,000 times this, I have to move the decimal place 6 times. So 1, 2, 3, 4, 5, 6 leaves me with 15 minus 30 plus 35, which is equal to negative 15 plus 35, or 20. So the cost is 20 something. The equation for the cost in dollars, so it's just $20. So the vertex is at 1,000, 20, which means you should make 1,000 tires, and it'll only cost you $20. Not bad. Okay, so that's a real-world example for finding a maximum or minimum value. You're just finding the vertex of a parabola, but it actually means something in this context. It's not just two numbers.